Module 2, Fundamental Forces of Flight, Basic Aircraft Controls, Engine Controls, Landing Gear. Today we'll delve into the fundamental aspects of aircraft operations, covering everything from the forces that enable flight to the intricate controls that pilots use to maneuver in the sky and on the ground. Part A. Fundamental Forces of Flight. Flight is made possible by 4 fundamental forces: lift, weight, gravity, thrust, and drag. Lift, generated by the wing's shape and movement through the air, counters the aircraft's weight. Thrust, produced by the engines, overcomes drag, the resistance of the air against the aircraft's forward motion. Part B. Wing design and lift. Wings are meticulously designed to generate lift. The wing shape and angle of attack determine how much lift is produced. The angle of attack is the angle between the wing's chord line and the relative airflow. This lift force allows the aircraft to ascend and remain airborne. Part C. Aircraft components and control surfaces. 1. Ailerons are located on the trailing edge of the wings. Ailerons control roll by moving up or down, thereby altering lift distribution and causing the aircraft to bank left or right. 2. Elevators are positioned on the tail of the plane or horizontal stabilizer. The elevator controls pitch by moving up or down. Changing the elevator's position will change the aircraft's nose position, up for ascent and down for descent. 3. Rudder, mounted on the vertical stabilizer. The rudder controls yaw by swinging left or right, aligning the aircraft's nose with the desired direction. 4. Flaps, found on the trailing edge of the wings. Flaps increase both lift and drag when extended. They are crucial for lowering the aircraft's stalling speed during takeoff and landing. Use of flaps during landing allows the aircraft to produce sufficient lift at a lower airspeed. The use of flaps allows this Cessna 185 tail dragger to land at a dirt airstrip located near Mexican Hat Mountain in southern Utah. Part D. Yoke or control stick. 1. The yoke or control stick is the primary interface for pilots to maneuver the aircraft. 2. It controls pitch, nose up or down, and roll, bank left or right. 3. Pulling back on the yoke raises the aircraft's nose, while pushing forward lowers it. A. To climb, gently pull back on the yoke to raise the nose of the aircraft and increase throttle to provide the necessary power. Monitor the airspeed and vertical speed indicators to ensure a steady climb. To descend, gently push forward on the yoke to lower the nose and reduce throttle to decrease power. 4. Rotating the yoke to the left or right will roll or bank the aircraft accordingly. Rotating the yoke to the left will roll the aircraft to the left doy. Rotating the yoke to the right will roll the aircraft to the right, C. Maintain a shallow bank angle of about 15 to 30 degrees for controlled turns. Once the turn is complete, roll the yoke back to the neutral position to level the wings. Part E. Rudder pedals. 1. Yaw control. Rudder pedals are used to control the yaw, left or right movement of the nose, of the aircraft, ensuring coordinated turns in flight. A. Pushing on the left rudder pedal will yaw the aircraft to the left doyd. Pushing on the right rudder pedal will yaw the aircraft to the right, C. The rudder is used to keep the aircraft coordinated during a turn doyd. If too much rudder is used, the aircraft will skid while turning. If too little rudder is used, the aircraft will slip while turning. 2. Ground operations. On the ground, the rudder pedals are mechanically linked to the nose wheel in most aircraft. The rudder pedals are used to steer the aircraft during taxi and runway operations prior to takeoff and after landing. Part F. Flaps and flap controls. 1. Purpose of flaps. Flaps increase wing surface area and alter its shape, enhancing lift at slower speeds during takeoff and landing. 2. Flap control lever. Pilots use a flap control lever to extend or retract flaps as needed for different phases of flight, such as approach and landing. Part G. Aircraft engine types and operations. 1. Piston engine. Common in smaller aircraft, piston engines use reciprocating motion to turn propellers and generate thrust. 2. Turboprop engine. Combines elements of a jet engine with a propeller system, offering efficiency and power suitable for regional aircraft. Part H. Engine controls. 1. Throttle. Regulates engine power by controlling fuel flow, crucial for adjusting speed and climb rate. 2. Prop lever. Adjusts propeller pitch angle to optimize engine performance across different flight conditions. 2. Condition lever. Found in turboprop engines, it manages engine speed and power settings. 3. Engine controls in single-engine aircraft. The Cessna C208 Caravan is a single-engine aircraft that has one throttle control lever, prop control lever, and fuel condition lever. 4. Engine controls in multi-engine aircraft. The PA-31 Navajo, Cessna Conquest, C441, and King Air 200 are multi-engine aircraft. These airplanes have dual engine controls for each power plant, 2 throttle control levers, 2 prop control levers, depending on the aircraft, and 2 fuel condition levers. Part 1. Landing gear. 1. Fixed versus. Retractable landing gear. Aircraft may have fixed landing gear permanently attached to the aircraft. Other aircraft have retractable gear that stows into the aircraft during flight to reduce drag. The Cessna C208 Caravan has fixed landing gear. The Piper Navajo PA-31, Cessna Conquest C441, and King Air 200 have retractable landing gear. 2. Landing gear controls. Pilots use a lever or switch to raise or lower landing gear as required for takeoff, landing, or in-flight emergencies. 3. Operating brakes. Hydraulic or mechanical brakes are used to slow down or stop the aircraft after landing. Pilots apply them using foot pedals, allowing for controlled deceleration on the runway. 4. During an emergency, it is important for the non-pilot to know the location of the landing gear handle or lever. Conclusion. Understanding these fundamental aspects of aircraft operations is crucial for non-pilots to be able to manage an emergency in the event the pilot is incapacitated. Each component plays a vital role in ensuring safe and efficient flight, from takeoff to landing. Thank you for joining me in this exploration of aircraft operations. If you have any questions or suggestions to improve these modules, please leave them in the comments section below.